Hello everyone, it's been a long time. My name is Remi. I am coming on the behalf of Behavioural, which is a market research smaller company, a bit smaller than Ipsos, specialized into packaging, so helping people select the best pack for helping consumer product good companies selecting the best pack. And we have developed a machine learning model that is predicting the KPI that we are gathering. And I will try to present how this behavioral AI can exist and keeps existing in a world where the world AI is more and more related to generative AI, so AI from the LLM. I want to start by introducing why we are focused on the packaging step into the whole life cycle of the market research. The packaging is a very high-stake moment because it is taking place in a few seconds at the shelf step. It is the last step for the shopper before he actually buys the product. And the shopper is confronted to a lot of stimuli because it's a hyper-competitive environment with a lot of different SKUs. There is a lot of different stimuli coming from the vocabulary of the claims, the vocabulary of the shapes within the pack. And so the kind of the idea, the belief is that we need a common framework to help the customer to decide on a pack, or to decide, sorry, on a new design for its pack. On top of that, obviously, selecting a pack design is a big growth lever, so it is obviously a big, important stake for our customers. And so we have come up with a framework where we divide the decision process into 4 scores: seen, shoppable, selective, and selected, that we can see as the path that the shopper is taking towards buying the pack. So seen is when he's far away from the shelf to see the pack but not see the details of the pack. Shoppable means that he's able to see the details of the pack amongst other pack. Selective, it's mostly the claims and what the pack is claiming to be, what the shopper is feeling towards the pack. And the selection is, of course, the most important step, where our shopper is actually selecting which product he wants to buy in a shopping exercise. And from this framework, we are starting to come towards AI. The big question for our customer is how, from a pack design, we can predict the market impact. And the answer we give to that is this. We are creating 2 AI models, predictive AI models, not generative. One which is predicting the data that we gather through survey, but only from the pack design. And the second one from these KPIs that have been synthesized by the first model. We have a formula of market impact that we are selling to the customer through the 4S model that I just defined. I know it's a lot, but in order to be able to dive into predictive AI versus generative AI, I needed to give some context on where exactly our product is situated. And so we have recently built a platform where the consultant, insight manager can upload an image, and we are showing the results of a study if such study was conducted. and through other machine learning models, we are also able to have a range of features such as saliency map with some nice transformers that are auto-detecting the claims. But what I want to focus on is really the machine learning model that is going from a pack to the KPI prediction. So everything that I said is true, was super valuable in the pre-transformers world, in the world before generative AI. But what has happened recently is that the models have become commodities. All the framework that I just explained could have been created by LLM in a few minutes. LLMs are becoming extremely cheap. You can upload an image of a bag of chips, like I just showed, and get exactly the same result that I showed by just asking ChatGPT to predict the values of the KPIs. But what is not becoming a commodity is the fact that in our industry, we are all, a way or another, sitting on a trove of data. In our case at Behavioural, it is all the KPIs that we have gathered across the years, and the way that we have segmented them across audiences and across customers, and the fact that we know if a test design has been selected or not. But I do believe that in every step of the market research, we do have this type of moat, and this is really this moat that is making predictive AI existing in a world where GPU can be rented very easily, or any model can be designed by LLM through the type of iterative process that was presented this morning, and where the training is not that expensive once we have this type of technology going on. The data that I am building my model on is a mix of behavioral and claim data. So we have some real-eye sensors that are looking at where someone is, how do we say that? Doing eye tracking. From the eye tracking data, we are defining some KPIs. We're also building some custom questions. We are able with some classifier to aggregate all of these questions into canonical KPIs. And thanks to all of this data gathering, we are able to build a we are able to do supervised learning and create a regression model with an architecture that I'm going to show you now. So with all this data, we have been on expertise. We have designed a model which is not only trained on the data, but also kind of encoding the belief that we have on the data with multiple modalities that are encoded through different encoders, then a fusion layer that is trained separately, and that's the part which is really specific, doing some multi-head regression, where the head are recompute depending on the family of KPIs. So it's a mix between some knowledge we have about how the data is gathered, and also some statistical analysis of correlation. And what is also specific to our data and the customer is that the last layer, the scores are calibrated depending on the audience and the categories, because what we are trying to predict is the percentile in which lies KPIs rather than just the raw score of the study. And we come up with this architecture that is both trained on the data modes, but also encoding directly in the architecture the belief that we have on this data. another thing that is also, I'm just showing you the numbers just to give you a sense of how many data points the model is trained on. It's not that much for a deep learning model, but it is something that is enabling, even if you get the architecture without a sufficient amount of data points, it is impossible to get to the same results. One other thing that we can do once we have aggregated all the data in a way that is matching the belief that we have and representing how it was gathered and how it is segmented is also to start using generative AI to create a retrieval augmented generation algorithm, which is so RAG, which is a semantic way of fetching data in the database. And because we have the scores through the algorithm and the scores on all the images, if we connect an agent through MCP on this RAG, we are able to deliver to the customer a way of knowing the scores of a product that is similar to the product that is submitted. So it's another way of, it's a way that is expanding the usage of the platform that I was just showing before, because it is making it more universal, since any agent can connect to the MCP that is powered by this RAG algorithm. So it is a way of operationalizing this database. What we are really trying to do, as I was mentioning during my introduction, is to deliver some decision grade AI. What we call decision grade, it's something that I think we talked about a little during the second talk this morning. It's becoming a consultant, which is upstream, so at the decision level, but rather than being an artisan through this process that I just showed, we can standardize the decision process. So it's kind of a mix between standardization and use of predictive AI and being a decision consultant, because the scores are standardized. And so I identified 3 pillars. I believe that there is 3 pillars for a decision grade algorithm. It needs to be deterministic, because if you are inputting twice the same input, in this case image, you want to have twice the same score, else you cannot take a decision. It has to be measurable, so you can compare the outcomes of the algorithm together. In this case, it's a score. And it has to be uncertainty aware. And what's nice with this type of regression algorithm is that you have a shape of probability at the output of the regression. So you always know in which variants you have the outcome. And it is not something Gen AI can do natively, and I will go further by saying that generative AI is unable to deliver this type of decision grade output by design, because it's non-deterministic. It is answering with a vocabulary, some words, and therefore it's complicated to attribute a score. If you ask it to give a score, it will give you a score, but it will be based on some reflection on words. And by design, it cannot be uncertainty aware. So that's kind of why predictive AI, even if LLM and agents are becoming an increasing threat, is going to still have a role in our industry in the years to come, I believe. And now, so generative AI, I just said, is not fit to completely replace the work of a market research consultant. But in the last slides of my presentation, I want to show that generative AI can be complementary and help optimizing the process of selecting a pack design, but by extension of selecting a product and helping the customer to make a decision. An example of that is an application that I am developing right now, which is using generative AI from a sentence and an image of a pack in order to generate claim variants and image of such pack with synthetic data at the position of the claim, and be able to test in the same algorithm both packs, so one with the original claim and the other one with the new claim. And so this way we can kind of increase the search space of the pack and come up with ideas that the designers did not have. And it's also a very interactive way of it's an interactive way for the customers to iterate a new design, and it's just matching the market as we're seeing today, going faster and faster. And if I am expanding on this idea, we could see that before, even with the AI product that I have presented, the choice of a pack design was linear. We were going from ideas to a study to a study or a simulation of a study with the algorithm, to gathering the data, then taking a decision, then moving on to the next product with the human on the project gathering some information and keeping some information, but not completely optimizing the process. And with generative AI, we could imagine that the iteration cycle and the optimization of the pack is going faster and faster. And so from one idea, we can create a lot of different variants, have them tested, select the best one, have them tested in real life studies, but continue this process iteratively, which is really making the idea space that we're exploring larger, and also removing some back and forth that we see happening between the customer, the design, and the agency, which is us. So not the design agency, but the market research agency. And in conclusion, in a world where AI means both generative and predictive AI, I believe that if what we want is to have decision-grade artificial intelligence, there is still room for accumulating real-life data and continuing to pour some expertise into structuring this data to continue to build the moats that I was mentioning, and use algorithms that are regression algorithms with all the three pillars of the decision-grade AI that I was mentioning included in this kind of built-in this algorithm to make this mode actionable. And generative came in by allowing us to generate more synthetic data to optimize the process and close this loop that I just showed, and expanding the search space, connecting agents through a RAG, and yeah, this is my conclusion.
Thank you very much, Remi. It was really nice to see a practical example of how you're using AI in a kind of a very specific but niche situation, which I think is something which is going to become more and more apparent in the future.
kind of a case study on everything that we saw today. Actually,
Yeah.
each slide could be like connected to one of the things that was mentioned during the conference.
Yeah, thank you. Does anybody have any questions for Remi?
Ooh. Question from Remi. From a client perspective, how much of their data is used to train or improve future models? And output for other clients, how transparent should AI providers be about this?
I did not mention it, but each customer, each client is getting its own model, which is fine-tuned on their design. But this is true that the core has been trained on signals that are coming from all the design at once. However, it is impossible to reconstruct the embedding. So I know that test pack, especially test pack, are a secret, but they are not. It's a destructive process. You cannot rebuild the pack from the signal that is coming out of the algorithm. So I guess that the question is, all of the data of all the customer is training the core of the system, but customer get some fine-tuned data, and especially the calibration data, the percentile, which is the result of their own studies. This is compartmented by customer.
Thank you. I have a question, if nobody else does. With AI transforming so fast all of the time, do you have like a shelf life for Pack.AI? So I suppose, do you go, okay, we'll do this for 6 months, but then we'll rebuild it using the latest AI which has come along? Do you have that kind of almost like roadmap in your head?
So it's exactly. Actually, I joined the company a year and a half ago, and it's very funny because what was mentioned during one of the talks this morning, I created exactly that. I have agents that are building a roadmap, and I am spending most of my day actually iterating on this roadmap, talking to agents, making them fetch new papers, and try to see if we can incorporate them into the software. And so, yeah, the idea is to get into this cycle of iteration with our customers where they're giving some feedback on the results. And we are incorporating this feedback and trying to find new solutions and new modules. So if I'm coming back to this, at first, we did not have a fusion layer, and we found out that the text was having too much importance on the variance from customers. So this fusion layer using the film for people who are deep learning proof technology was an idea of one of my agents. Same for the multi-head regression. At the beginning, it was one model per head, and multi-head was a way of having kind of all the KPI going in the same direction, because our customers were unhappy to see that some pack were deemed more visible but less seductive, for example. So this is the way to go.
It feels like a never-ending journey that you have to keep iterating to keep staying on top.
It's fascinating.
Okay, thank you very much.
Thank you.
Thank you.